the last couple of years, a new technology is introduced into our industries. LEDs, light emitting diodes. Light emitting diodes are semiconductors. So this means they work instantly when power is applied. Light emitting diodes emit, we call it quasi-monochromatic light, which is a very narrow band of wavelengths. Actually, LEDs, UV LEDs, are available and efficient in the UVA range, starting at 365 nanometers, going up to 405 nanometers. In general, the shorter the wavelength of a LED is, the less effective the LED is, meaning the effectivity is lower when the wavelength is lower. To give you an example, if you put in 100 watt of electrical energy into a line of LEDs, you will have an UV output of approximately 40% at a wavelength of 395 or 405 nanometers. That decreases to approximately 60% of these 40% at 365 nanometers. As the LEDs only emit a certain wavelength, which is in the UVA range, there's also no generation of infrared radiation, which is the case with conventional gas discharge lamps. And another important fact, since the LEDs only work in UVA, they are not generating ozone. Ozone is known as a variation of oxygen, and ozone is generated only in a wavelength below 250 nanometers. The LEDs do not generate these wavelengths, so ozone as well is not generated. We already talked about functionality of LEDs. We talked about wavelengths, and now it's time to discuss a little bit more about environmental issues. In a conventional UV system with medium pressure lamps, you will have lamps with mercury inside, and these lamps emit, due to the wavelengths they emit, as well they generate ozone. This is not the case with LEDs. LEDs do not include mercury. They do not generate ozone due to the wavelengths. This is clearly a beneficial aspect in terms of environmental friendliness. In addition to the environmental aspects, the LED have a higher lifetime expectancy. We'll expect LEDs to have a lifetime of about or above 20,000 hours. Compare that to a conventional medium pressure bulb with about 1,000 to maximum 5,000 hours. As the LED is a semiconductor, we can instantly switch it on and off. We have no heat up phase like in conventional UV systems. We also can do format settings, meaning if the printed sheet is smaller than the maximum sheet size, we switch off LEDs. We have no mechanical parts in the LEDs, so also in terms of maintenance, the LED has some benefits. As the LEDs only emit UV radiation in the UVA sector, you need adapted consumables such as inks and coatings for these wavelengths. This means the ink supplier has to modify his ink make it more reactive and make it more sensible in the UVA sector.